Okay, so we've been talking about data and we've been displaying different types of data in different ways. So we've had our histograms, then we've had dot plots, whatever, and then we've also had our stem and leaf plots and so on. Okay, so we've been describing the data displaying it, and now we're going to describe it. And remember, one of the three things we had to when we were describing, we often described the shape, which was either symmetric, positive skewed, negative skewed. You then commented on the center, which is so the center is you either comment on the median or the mean, which we're going to do today. And then the last comment we'll talk about is the spread. If you remember, that was like the range and the IQR. Okay, so today we're going to look closely at calculating the measure of center for certain pieces of data. So one measure of center is the mean. So the mean, we often see the symbol, the X with the line above it. That's the symbol for mean, and that's what you'll see on your calculator. So when you do a list statistics and you get all the data up, the mean is the very top one. It's the first one mentioned. So the mean is also known, we often in common language, so you might write common language, the mean is known as the average, yeah? Equals the average. So we know when we're working out our average, we add them all up and we divide by how many there are. So what we're going to do, we've got that formula written out. So when we talk about the sum of data, this symbol here just means that the sum of the data means you add all the data up. So if you want, you can just pop that above there. So if you ever see that, it just means add it all up. We probably won't test you. We probably would always say it in words if we want to, but just so you know, this is a brief little summary for the mean here. So you add all the data up and you divide by how many data pieces you have. So for this example here, it said consider this set of data. So you can see you've got your 1, 2, 3, 4. So you have 4 pieces of data, so n would equal 4 here. So you can see they've added all the data up, divided by 4, and this was our mean, okay? So that's one measure of center. So if we were talking a little bit about it last week, but remember, we might write it out again. Remember, the mean is a good measure of center for symmetric data. Symmetric data with no outliers. So with no outliers. So really, when we're talking about it, you might want to put a little example. So when you have those histograms that are nice and symmetric, yeah, that's symmetric data. So the mean is pretty much only good for that type of data. All right. So another measure of center is the median, and here is highlighted is it is a resistant statistic and not affected by outliers. So the median is a little bit different. So the median is when you're going to arrange all the numbers from smallest to largest. So say if I made up a little, let's do a little example here. If I had these set of numbers, so I'm just making that. So you can see I've gone from lowest to highest. So if you order them, this is the median. The median is just the number that's sitting in the middle. So if you have a look at this data, this one would be the median. So can you see there's 2 numbers listed before it and 2 numbers listed above it. So that's the median. Now this one is not affected by outliers. So if I was to find out the average or the mean, I would add them all up and divide by how many. But with the median, I just put them in order. So can you see, if I changed this number here, if I changed that to say 1,000, that is definitely an outlier in this set of data. But can you see the median didn't change, did it? If I was to calculate the mean, the average, it's going to change greatly, isn't it? Because of that big 1,000. So that's what we're talking about when we say this median is a resistant statistic, and it's probably a better indication. We don't like to look at the median because it's telling us where is all that data sitting, and it's sitting right around that number there, okay? So the way we can find it, so just be careful here. Just want you to make sure, highlight this, and just make sure you make that this is a way to find the median. So it's not calculating it, you're sort of finding it within the list. So you find the median, okay? And obviously, so we're going to use this formula, and you're going to see when we have odd numbers. So what we mean by that, see up here in my example, I had n equals 5. When you have odd numbers, it's easy sort of to locate the median. It's the middle value. If you have even numbers, you have to add the 2 middle values. So we'll give that a go, and we're going to do some examples. All right, so let's have an example of, we're going to go through this. Okay, so let's have a look at this example here, this example number 1. If you have a look there, n equals 11, okay? So there was 11 numbers listed here, and we can see they have been listed from lowest to highest. So that's good because they need to be. So the way we will find the median, so to show how you can use that formula, so to find the median, we use the formula n plus 1 divided by 2. So in this example, n is 11, so 11 plus 1 divided by 2, so you'll get 12 divided by 2, which is, so it's the median's going to be in the 6th position. So when you count through your data, this is 1st, 2nd, 3rd, 4th, 5th, 6th. So that's why this number has become the median, the 6th value. So if you look down here at example number 2, we have an even set of data. So you can see that n equals 12. So what you do, you can still use that formula, so n plus 1 divided by 2. So to be 12 plus 1 divided by 2. So we get the 6.5 position. So what that means is between the 6th and 7th value. Okay, so if you count through the data, 1, 2, 3, 4, 5, 6, 7. So these are the 6th and 7th. So the number in between those. So the way you can find that is you can go 6 plus 7 divided by 2. So you can add those two together and you'll see it's 6.5, and that's why they said the median was 6.5. So we could type these lists into our calculator and do a stat calc, and it would tell me the median. But this is crucial that you know how to do this on the paper, because it is actually technically quicker to do it like this. When you only have a small set, you are going to be quicker than typing it all in, okay? So very important that you can do this without your calculator. So let's have a look at a stem and leaf plot. So with a stem and leaf plot, remember that the leaves are how many data you have. But as I said, sometimes these questions, they're a bit nice to us and they tell us here. So it says, find the median age of these 23 people. So this is where I said I don't need to worry or count out all those leaves. They just told me there was 23. So when I go to find the median, remember I can find the median at n plus 1 divided by 2. So in this case, it'd be 23 plus 1 divided by 2. So it's going to be the 12th spot, okay? So what you've got to do is you count through the leaves. So remember, a stem and leaf plot is ordered, meaning it does go from lowest to highest. So you'd go through here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this number here, the 4, and this leaf there is our median. So reading the key, what's my median for this data? Yeah, good. So the median for this set of data equals 41. So you're going to find that for me was going to be quicker than typing that whole list into your calculator. You would have had to then type in all the 23 numbers and that. So you can see this is a quicker way to work out the median, and time is everything for your exams. You need time. Okay, so let's do this next one. The median age for the group of people whose ages are displayed in this ordered stem and leaf plot. So they didn't tell me how many, like the total number of data. So if you counted up all those leaves, you would get, we end up with 18, okay? So there was 18 leaves there, so we know that n equals 18. So when we go to find where the median is, we'll find where the median is using the n plus 1 divided by 2. So it'd be 18 plus 1 divided by 2. So it's going to be, that would be 9.5. So remember what that means? It's going to be between the 9th and the 10th value. Okay, so then when we go, we're going to go back to our data and we're going to count up to that. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the 9th value equaled 34 and the 10th value,
39.
Yeah, equals 39. So if you trying to find the median, we're going to do 34 plus 39 divided by 2, which is going to equal 36.5. Okay. We looked at if we were describing this data, and we're gonna pop that in underneath just to practice. So if I was describing this data distribution, okay, so this is what you'll get asked, or if you have to write a report on it. I'm going to say the shape. What do you reckon the shape, this one's shape was? If you turn it on the side, looks, yeah, I'm going to say symmetric. So that was me commenting on the shape. I'm going to say it has a center at 36.5 years. Okay, and then we might say it has a spread of, and we'd have the maximum minus the minimum, so it was 63 minus 5, which would be 63 minus 5 would be 58. Yeah, a spread of 58 years. So if you want, we just did the range there where we did max minus min. Okay, so look at this one. Okay, we have a dot plot here, and it says find the median of the display of the data displayed in the dot plot below. So if you counted all the dots up, that would tell you how much data there was, and I've already counted them up for us. So we've got 19. So if we go to find the median, we're going to find the median at n plus 1 divided by 2. So 19 plus 1 divided by 2. So it's going to be the 10th position. So if we count through our data, so with the dot plot, you'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So sometimes they get you to circle the median on the graph. So there you go, there's your median, you've circled it. But if we were writing it out, what is the median? What's the actual number of the median? Where's that dot sitting?
5.
Yeah, in a 5. So the median is 5. Okay, so in plenty of Year 12 exams, they ask you to circle the median on the graph. So that's where you need to do that. And that would be a way they would test you without knowing the calculator. So if you don't know how to do it, the calculator is not going to circle the median on your graph ever. So you're going to have to know, you might know it's 5, but which dot is it? There's like 5 5s there. So which dot of 5 is the median? It's that 10th one there. Okay, so let's do the next one. Find the median of this set of the dot plot below. So with this one, n is 20. So when we go to find the median, it's at n plus 1 divided by 2. So it's going to be the 10th. We get 10.5. So what's that mean? It lies between what? Between 10th and the 11th. Good. So if we go through, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So the 10th value was a 3 and the 11th value was a 4. So when you're finding the median in even sets of data, you add those two together. So 3 plus 4 divided by 2. So what would that be? Yeah, 3.5 equals the median.